Hello, so this is the continuation report of the concepts of probability. So let's start with stem and leaf diagram. Stem and leaf diagrams are like histograms, turned on their side with data magnitudes to two significant digits presented rather than only bar heights. Para mas maintindihan, magbibigay ko ng example. So, dito sa case processing summary table natin, makikita natin na na-count lahat ng score sa dataset natin kasi 100% siya at yung total natin ay 100. So, pag tinignan natin yung ating stem and leaf plot dito sa stem width, by nakalagay na 10. So, ibig sabihin, yung stem dito na 5 at 6, kailangan natin i-multiply sa 10. So, this means 50, 60 at saka 70. Dito naman sa leaf natin, counted yung leaf as one case. So, ibig sabihin, pag ito ay 4, babasahin natin siya as 50 plus 4, which is 54 at saka 55. Kaya naman, dito sa frequency, may nakalagay na 2 kasi dalawang data yung nandito natin. Yung 54 at 55. Dito naman, 4 kasi referring to 56 at tatlong 57. Now, pag tinignan natin yung top part natin, nakalagay dito na frequency ay 0 kasi wala tayong score na 50. Dito naman sa lower part natin, may nakalagay na 2 extreme values, meaning we have values greater than or equal to 76, which are extreme. So now let's proceed to the quantile plots. So let us first know what is quantile. Quantile is a percentage of points below a given value in our dataset, often referred to as percentile. So now let's know what is QQ plot or the quantile or quantile to quantile plot. Is a probability plot a graphical method for comparing two probability distribution by plotting their quantities against each other. So here's the figure that we can see the comparing two probability distribution. So the two probability distribution came from population with the same distribution of point fall approximately along the 45 degrees reference. So as you can see, yung ating points is along 45 degrees yung reference line nila. So itong figure na to is point X and Y. On the plot corresponds one of the quantiles of the second distribution is the Y coordinate, which is nakikita natin yung normal data quantiles. And the plotted against the same quantiles of the first distribution, which is the X coordinate, is yung ating normal theoretical quantiles. So let's proceed to the box plot and the outliers. So bago natin yan makuha, kailangan natin munang kuhanin yung 5 number summary natin. So, yung 5 number summary natin give us a way to describe a distribution using only 5 numbers, which is the minimum, first quartile, median, third quartile, and maximum. So, kapag kumuha tayo ng sample at i-measure natin yung random quality ng variable, kailangan natin i-arrange from smallest to largest. 5 summary to describe the distributions. Yung minimum is the smallest value and yung maximum naman is the largest value of the data set natin. Yung median is the middle data value. Ito yung point na 50% of the data are below the median and 50% of the data set are larger than the median. Now, the median of the bottom half is called the first quartile. Ito yung position na 25% ng data values are below it and the 75% of the data set are longer than it. So, the first quartile is yung median of the median. The same din naman siya sa third quartile. So, the median of the top gives the third quartile and it is position where 75% of the data values are below it and 20% of the data values are longer than it. So, yung 5 number summary natin ay meron siyang 4 equal orders. So, now let's determine the 5 number summary from the following data set. We will start in the median. So, yan, hahanapin natin yung ating median, which is 33. Pwede natin gamitin yung formula na position of median is equal to n plus 1 over 2. So, lahat ng mga dataset natin is 15. That's why 15 plus 1 over 2 is equal to 8 and it is 33. So, yung first quartile naman natin, pwede natin gamitin din yung formula na yon. So, n refers to the number of data values below the median. So, there are 7 data points below the median. So, yung n natin is equal to 7. So, 7 plus 1 over 2 is equal to 4. So, we count to 4th position and ang ating first quartile is equal to 25. So, para mahanap naman ang ating third quartile, ganun pa rin except sa n refers to the number of data values that are above the median. So, there will always been symmetry at mahanap natin na yung Q3 is nasa position of 4 din siya, which is 36. So, now ang ating minimum number is 10 and ang ating maximum number is 59. So, as a result, yan na yung 5 number summary natin. At this is the time na makukuha na natin yung box plot. Box plot give us a usual representation of the 5 number summary. And it took something like this. Each vertical line on the box plot represent the numbers from the 5 number summary. Yung horizontal line na naka-extend sa box is called the whiskers. And yung box is called the interquartile range. The interquartile range refers to the middle 50% of the ordered data set and is equal to the third quartile minus the first quartile. So we can have something called the modified box plot. It is like a regular box plot except that meron siyang outliers. So sometimes outliers in the dataset aren't that obvious. However, we can mathematically check if the dataset has outliers in it. So we said that a data value is considered to be an outlier if data value is less than Q1 minus 1.5 times IQR, or data value is greater than Q3 plus 1.5 times IQR. So if ma-remember natin yung number of the following dataset natin and we have calculated the 5 number summary to be 10, 25, 33, 36, and 59. To check for outliers, we first need to calculate the interquartile range. So we find that Q3 is equal to 36 and Q1 is 25. We simplify this, we can get an answer of 11. Now, we said that a data value is an outlier if it is less than Q1 minus 1.5 times the RQR, or if it's greater than Q3 plus 1.5 times the RQR. At this point, mag-start na tayo mag-substitute. Yung value ng Q1 natin is 25, yung Q3 natin is 36, yung IQR naman natin is 11. And so we can say that the data value is considered to be an outlier if it less than 8.5 or if it is greater than 52.5. So, if we look at our dataset, we see that no values are less than 8.5. However, we do have a value that is greater than 52.5. Therefore, we see that 59 is an outlier. And so, if we make a modified box plot, we write the outlier as that, and the whisker will only extend to the new maximum. In this case, it is 50. So, a quickly recap, a regular box plot uses the 5 number summary. A modified box plot also uses the 5 number summary, but it counts for outlier. If there are outliers, a whisker or both whisker will only extend into the new minimum or maximum. And that's conclude my report. Thank you so much.